Welcome to AVN Knowledge. Today we will study about the electric current, and here we take the combination of cells. When two cells are connected in series combination, what is the EMF and what is the internal resistance? When two cells are connected in parallel combination, what is the EMF and what is the internal resistance of cell? So here two cell E1 and E2 are connected in series combination, and the internal resistance of this cell R1 and this cell is R2. So this is a cell and this is another cell is connected in series combination, and this is the internal resistance of R1 of this cell, internal resistance R2 of this cell, and a external resistance capital R is connected by this cell, and current flow is I in this circuit diagram, and this is a equivalent diagram. This is equivalent diagram means E equivalent when two or more cell are connected in series combination. What is the equivalent EMF of this cell, and this is the R equivalent. So this circuit is equivalent of this circuit diagram, and this is the equivalent cell. What is the equivalent cell? When we combine between 3 cell or 4 cell or n cell are connected in series combination, that will be the E equivalent of EMF of the cells, and R equivalent is the equivalent resistance of all cells. So we can write what is the potential difference between A and C. So we can write VAC equal to VA minus VC. The potential difference between A point to C point. So we can use VA plus B or minus B. Plus B and minus B, and this is the VAC. So this equation, a potential is minus B and potential is plus B in this equation. So we can write this equation like this: VB minus VC, and this equation is equal to the VAC. And what is the VAB? We can write VAB plus VBC in this equation. What is the relation between terminal voltage, EMF, internal resistance? We have already studied the basic formula: E minus V equal to I into R. This is the basic formula. When you use the potential, what is the potential? Potential is E minus IR equal to V. So here, what is the potential between A and B? This is A and B. A cell is used E1, current is I, because in series combination current will be same. So I and internal resistance is. So this formula is used in this circuit diagram, that is E minus I, that is the E1 for between A and B point, that is the E1, minus current is same, and potent internal resistance, that is the R1. Same formula is used for between B and C. B and C, cell is E2, internal resistance is R2. So E2 minus I into R2. So the potential difference between A and B, potential difference between B and C, we use the standard formula E minus V equal to IR for this equation, that is the VAC. This is the equation 4. Solve this equation, we can use E1 plus E2 minus I R1 minus I R2. When taking the I1 common, then you can say minus I R1 plus R2. This equal to VAC. This is equation 5. When we use the equivalent diagram, what is the VAC? For this circuit diagram, what will be the VAC? This VAC will be equal to the E equivalent minus I R equivalent. This is the equation 6. This equation comes from this equivalent circuit diagram. The VAC between A and C, E equivalent minus I, current is I and internal resistance is R equivalent. From equation 5 and 6, compare equation 5 and 6. What will be the equivalent? VAC is same, E equivalent will be equal to the E1 plus E2. And what is the R equivalent? R equivalent equal to R1 plus R2. So for two cell combination, what will be the equivalent EMF? Equivalent EMF equal to E1 plus E2 plus. And what is the R equivalent? R equivalent is series combination R1 plus R2 plus R3. If we use the N cell, the EMF is E1, E2, E3, so on, En. Internal resistance R1, R2, R3, so on, Rn. What will be the equivalent EMF of this cell? That will be the E equivalent equal to the E1 plus E2 plus E3 plus so on En. And what is the R equivalent? R equivalent equal to R1 plus R2 plus so on Rn. So this EMF, equivalent EMF of this cell will be in series combination, that will be E1 plus E2 plus E3 so on E1, and R1, R2, R3 internal resistance when N number of cell is connected in series combination. What will be the current? When we use the current, the current is I equal to R plus R equal to E. When you use this equivalent circuit diagram, you can say this is the R, I equal to, this is equivalent. So E equivalent, R equivalent. For the equivalent circuit diagram, R and R equivalent in series combination, I will be E equivalent upon R plus R equivalent. This is the current in this equivalent circuit diagram. What is the E? R, capital R, and is R equivalent in series combination, I equal to V, R plus R equivalent equal to E equivalent. So I equal to E equivalent R plus R equivalent. Here N number of cell, same cell, EMF are same. If EMF is same and the cell is N. EMF is same means E1 equal to E2 equal to E3, that equal to E, and the number of cell is N. Then what is the E equivalent? The E equivalent will be N into E. If the same internal resistance R1 equal to R2 equal to R3 equal to R, then what is the R equivalent? R equivalent equal to N into small r, that is the R equivalent. When N number of cell, same EMF are connected in series combination and same number of cell are in parallel combination, then what will be the current? In this situation, the current equal to N into E upon R plus NR. That is the I. When EMF of the cell are connected in series and same EMF and same internal resistance of cells In this particular condition, the EMF will be N into E, internal resistance will be N into R, and current will be NE into R plus NR. When third condition is cell are interchanged. In this condition, when cell are interchanged in the circuit diagram, what will be the E equivalent? Suppose this cell E1 plus minus, that is the E1, and another cell is minus plus, that is the E2, and this circuit diagram is like this. So here this is positive, negative, positive, negative, positive, negative in series combination. When I interchanged positive, negative, negative, positive, or you can say negative, positive, positive, negative, when the cell terminals are interchanged in series combination, what will be the R equivalent or E equivalent? So here R equivalent, that is the R1 plus R2 plus R3, but E equivalent will be changed, that will be E1 minus E2. The terminal is changed in series combination, the resultant EMF will be E equivalent equal to E1 minus E2. So when we use the same terminal plus minus plus minus plus minus, then that will be added. If terminal changes plus minus, minus plus, plus minus, then this will be also changed. So the basic concept of combination of cells in series combination, that will be the conditions like this. Kindly subscribe this channel AVN Knowledge, and if you have any comment or any doubt, comment on this channel. Thank you.